Okay, number 39 from 7.3, we're still doing combinations. They give us 3j plus 5k equals 19 and so on. We want to be able to cancel these out, but nothing's ready to cancel out. Like if this was a plus 8k and this was a minus 8k, then they would cancel and we could proceed. But they're not, so we've got to figure out a way to get these to cancel. And this ends up looking like, or feeling a lot like, finding a common denominator between two fractions with, denominators that aren't the same. I'm going to go after the 3 and the 4j. I'm going to multiply this times 4 to get this to turn into 12, and this one times 3 to get this one to turn into 12. So in this case, we have to sort of multiply each other one by, the factor that's in the other one. I don't know if the wording of that doesn't make as much sense as it does just to look at this. 4 times 3 gives us 12, 3 times 4 gives us 12, so that's how we got to go about it. Unfortunately, 4 times 3 is going to give us a positive 12, and let's go ahead and rewrite this. That would give us a positive 12j, and obviously it's just coincidental or incidental, I should say, whatever this turns out to be. What's that going to be? 36, 4 times 19, no, 76. So this would give us a positive 12j, which is not good because they won't cancel out. But if I make that a negative 3, I could also have made the 4 a negative and not made this negative, either one. I want to give one of them a negative so that they'll cancel out. So negative 3 times positive, or negative 8 would be positive 24k, and then this would be positive 12. So, which I don't necessarily need to write the positive. These are going to cancel out now. We're ready to go. And that's the essence of the technique. The rest is just algebra. 44k, and what's this? 88. Divide by 44. Divide by 44. K equals 2. And then to find out what j is, we just grab one of our original equations. 3j plus 5k, which now we know k is a 2. And so we get 3j plus 10 equals 19. Subtract 10 from both sides. That would be 9. 3j equals 9, so divide by 3. J equals 3. So now if we put them in order of j, k, then j is 3, while k is 2. So 3, 2 is our point of intersection. 3, 1, 2. If this is indeed j, the j-axis, and this is the k-axis, that would be the point of intersection right there. And we found it by combinations. And if we wanted to be very sure and check, we could plug this back in, j and k, and see if it gives us a true statement. Then we would also do it for this other one and see if it's a true statement. And a lot of my students start cringing when they get to this level because they've already done this much work, and plugging it back in is, a whole bunch more work. But that's what you got to go through to get the answer, and that's what math is. This is why math probably wears a lot of students out and weeds out the weaklings, so to speak. It's the students who go the extra mile plugging stuff in. They're the ones who are going to develop the skills, the careful skills, to be able to be successful in technical jobs such as engineering, computer software development, or whatever you pick as your career that requires math. So there's combinations again.